So in the last of these videos we've got slightly more complicated. These are much less likely to occur on the exam, but good workout for those of you wanting to push yourself to see how secure your understanding of this topic is. So the following reaction is carried out in ethanol and has a Kc value of 30. Okay, calculate the number of moles of HCN that must have been at the beginning to produce 1 mole of product, starting with 4 moles of propanone and 2 decimeters cubed of ethanol. So what information did we have? Well, we had the ratio was 1 to 1 to 1. We were told at the start that we had 4 moles of propanone, so that's gone in there. And we were told at equilibrium that we produce 1 mole of product, so that's gone in there. We knew we started with 0 product. Now, we're going to because we don't, what we're trying to find, remember that the thing that we're trying to find is the number of moles of HCN. So we don't know that, so we're going to give our unknown the x there. So what have we got? Well, we know that that one goes up by 1, the product goes up by 1. So since the ratio is 1 to 1 to 1, then the change is 1 to 1 to 1. Apply that, we've got 4 take away 1 is 3, x take away 1 is x minus 1, and nothing add 1 is 1. Work out concentrations. Well, what was our volume? Our volume was 2. Remember that concentration is moles over volume, so this is 3 over 2, or 1.5. This is x minus 1, brackets all over 2, so be careful. And this is 1 over 2, which is 0.5. Let's write the expression for Kc. Let's substitute in what we've got. So we've got Kc value was 30. We've got the product concentration was 0.05. We've got one of the reactant concentration as 1.5, and we've got the other one as x minus 1 all over 2. Rearrange to find x. What I'm going to do is, because x is on the bottom line and that's not helpful, I'm going to times both sides by this big bracket. Okay, so I'm going to do that. I'm going to do 30 times x minus 1 over 2 equals 0.05 over 1.5. What I'm going to do now is I'm not going to expand the brackets. Expanding the brackets is tricky, so I'm going to divide both sides by 30. Now, if you find the algebra trick, you could work out what 0.05 over 1.5 is if you want. But I'm going to just do this, x minus 1 over 2 equals 0.05 divided by 1.5 times 30. Just ignore that page number there. You can type that in your calculator now if it helps you. Okay, so you could find out what that is on your calculator. 0.05 divided by 1.5 with a 30 on the bottom line as well. We've got 1 point, so we get x minus 1 over 2 equals 1.11 times 10 to the minus 3. So I'm going to multiply both sides by 2. I get 2.22 times 10 to the minus 3. And then I'm going to add 1 to both sides. And I get 2 points. Oops. I get 1.0022. So 1.0, let's have a look at our significant figures. 3 significant figures, 1.00 to 3 significant figures. Mole dm minus 3 is a concentration. Okay, so that was a little bit trickier because there's a bit of algebra at the end. Our very last example is even trickier, but we will have a go at it. So first of all, let's just write down the expression for Kc and calculate units. We didn't need to calculate units, did we? Because it tells us that there are none, because we've got the value for Kc there. Let's use our RICE method. So let's lay it out. We've got hydrogen plus iodine in an exam makes 2Hi. We write RICE down the side, RICE, and then I put the square brackets for concentration at the bottom. we're starting off with our ratio, 1 to 1 to 2, our initial amounts, so let's go find them. So we go up here, and it just tells us equal amounts, and we don't know what, we're being asked what one of them is, so we don't know what it is, so that's where we're going to put our algebra. Equal amounts, so the same number, we don't know what it is, put it in there as the initial amount. And we'll have 0 products. And then our equilibrium, we have got 1.4 HI, so that's our equilibrium amount, 1.5 moles of this. So that changes plus 1.5. Now that, if that's the 2, then these two are 1s, these would be minus 0.75, half of that. So we'll have x minus 0.75, and then another one x minus 0.75. And we're quite lucky here, the volume is a 1. So we've got x minus 0.75, because if you divide by 1 you don't change the number. Let's put everything into our KC expression. So we had 64 equals 1.5 squared divided by x minus 0.75, x minus 0.75. Now, a mathematician would approach this in a different way now, probably, because in maths there would be a negative value for x as well as a positive, because we've got a quadratic, but there can't be a negative value for x in this chemical equation. We can't have the negative root, we can't start with less than 0. So what we can do is appreciate, and this is why this is an extension question, we can appreciate that actually, if we look at it, we could rewrite this as this. We've got a squared number on the top, squared number on the bottom, because we've got x minus 0.75 twice. We've actually got a squared number on the right as well, on the left, sorry. So why don't we just square root both sides? So square root of 64 is 8. Square root of 1.5 squared is 1.5. Square root of x minus 0.75 is squared is x minus 0.75. Now the algebra becomes a lot easier. See if you can finish it off. And if you've managed that, that's what you should get. Now those last two examples, they are quite tricky and a bit beyond the level expected in exams.